You are welcome to another section of algebra or calculus 1. So that's basically for first year students in science taking algebra. Again, I'm your tutor, Miss Egan. Today I'm looking at unit 2 of indices and logarithms. But in this video, I'll just take that of the indices. Okay. So in logarithms, we are going to look at two forms, the common and then that of the natural logs. But today I'm covering that of the indices. So follow me with my write-up and my slides. So mostly we're able to write certain numbers and express them. Like what I have in my write-up here. If we know 2 to the power 3 is equal to 8, how? We just know we have to multiply 2 3 times to get the 8. 4 to the power 2 is 16. How was that? We know it is 4 multiplying 4. So it means that we are multiplying the number in the multiple times of the power or the index given. So indices is simply, I can use the word index or the power or an exponent written in this form. If I have a to the power b, or a to the index b, a to the exponent b, it means I'm multiplying a b times. And that is all about indices. It is a base raised to an index, or a base raised to an exponent, or a base raised to a power. We can express them in such form. So that is what I have on slide 2. Now, how do we express this? We can use certain things called the indices rules or the laws governing this. I'll take you through the rules one after the other so you follow me. The rule 1. Rule 1 says that don't forget these are your bases. A and A are bases. M and N are the index or the power or the exponent. If you have two bases multiplying and they are the same, what do? You simply take one of the base because they are the same, and then you add, I did a mistake here, and then you add the exponent or the index. That is the interesting thing here. Again, if the base are the same and they are dividing, then we take the differences in the index. So this is basically when the base are the same. The key word here is the same base. You pick one and then you either do something with the indexes. Now in the case where the indexes are the same, like that of so I've tackled rule 1 and rule 2. So it's the same rule 1. I'm calling it rule 1b. Now I can have different different base. I have A and B. They are different. They are the base, but they are different bases. They're not the same. But then my indexes M and M are the same index. What I can do is that I can combine the base and then raise to the same index because it is multiplying. So multiplication for same base, multiplication for same index. See the differences here for me. In the same way, if the bases are different but the indexes are the same, so to the power m to the power m, what I can do is to put these two bases together and then raise it to 1 power m. I hope the difference is clear. So you don't just always go by this part without watching the bases or the indexes. Okay, now the fourth rule says if I have a and then the index are dividing, it's like the nth root. We call the nth root. So how do we know that 2 to the power half is root 2? It's the nth root. So it means the root here is what? 1. Okay. 2. So this means I have the 3 square with the root of 3, or cubic root of 3 square, and that is it. Now there's another property that is rule 6. It says a base to the index 0 is 1. Why do I keep making such mistakes? Sorry, is 1. Any number to the power 0 is 1. We've believed this right from JHS to SHS to the university. It is from indices. So even if it's 1,000 billion and then the index is simply 0, it is 1. We don't care the number. Don't say, but madam, the number is so big. Indices rule says that if the base is raised to an index 0, the answer is simply 1. I think I forgot one rule, that is rule 5, that says that a base to a negative index, it is 1 over that base and then the index. There's a reverse or reciprocal rule. So if I have 2 to the power negative 3, it is simply 1 over 2 to the power 3. That is it. Now let's take some examples. So I'll go to slide 4 for me. I'm done with slide 3. Examples here. You realize I have 2, 2, 2, 2. 2 is the same as this. They are not different. It's the same as that. The base are the same and they are multiplying. What I can do is to add the index. This to the power 1, but we don't write that. You know, in mathematics, we don't write to the power 1. And then you should know the answer. This is the same as 2 to the power 6 plus 1, 7. You can use calculator to do this. In the same way, if I have this, let's look at the second one here. Because the bases are different but the index are the same, I can simply multiply 3 by 4 to the power 2 and you should know the answer. This is the same as saying 12 to the power 2 or 12 square, which is I think 144. Alright. Rule 2 example, the same base, so I can simply take one of the base and then this rule says you must subtract them. Now the subtraction is in this sense, it's as if you are bringing these two up here. You know, division and multiplication has a reciprocal rule, so don't confuse yourself and say why is it negative, why not divided. It's as if I'm taking that of rule, this rule, into account. So this is simply 2 to the power 3 times that. If I have to add them, what am I doing? I'm simply subtracting them. It would have been, and then some of you be, it would have been 3 plus negative 2. Positive negative is negative, so there's the to the power 1 and we don't write 1, so it's just 2. So I can clean this one now. Now to the next part, we have different bases by the same index, and so I can simply take the bases to the power 1 of the index, and that is, if you know your multiplication table very well, I know this is going to be 2 to the power 2, which is 4. This is simply, it says that when you have a base multiplying 2 indexes, don't care or don't bother with the bracket. You can just take off the bracket and multiply this, guys, and that'll be 4 to the power 6. I don't know what the answer is. 3 to the power negative 2 by the index rule of reciprocal. This is the same as 1 over 3 square, and that's 1 over 9. In the same way, if I had 3 to the power, let me not worry myself. This is just fine. Now there are cases where you can have combinations of these rules. So like if try 1. By board mass, we have to apply board mass here. That is BOD. There are some operations in mass that should be tackled first before the other. And we all know this. So with board mass, it means I have to cater for the bracket first. If I'm doing that, the same base, so I can simply add the index. This is dividing 5 to the power 1. This is 5 to the power 5 over 5 to the power 1. And by division rule, this is simply 5 minus 1 because of the division here. So I do the bracket first, and then I do the division. Bracket, I add the index, division, I subtract. And that's 5 to the power 4. I don't know what the answer is. The second example, board mass. There are two different brackets, so I can simply tackle this guy. The same base, 1 is raised to the power 1. You know this is the power 1. 1 plus 5 dividing 3 to the power 5. Ooh. So this is 3 to the power 6 dividing 3 to the power 5. And what would it be? By the reciprocal inverse rule, sorry, this is 3, 6 minus 5, which is 3 to the power 1. And that is 3. And this is how simple these things can be by applying the rules. But look at trial 4. We are given 4p square q whatever. We are given the values of them and we are asked to evaluate it. So it means I have 4. P is giving us 2, so 2 square. Q is giving us 1 over 2. And then R is giving us 3 over 2 cube. What do you do? Let me use a different ink here just to differentiate what I'm doing. Okay, so it says 4 times P giving us 2 square times Q, which is 1 over 2, times R, which is 3 on 2, but R is raised to the power cube. What is the answer? And by indices, we don't have the same basis or whatever, so please take your time and then see what this can be. Okay, I have the answer as 27. Prove that for me. Now to the problem of the day. We are in National Science and Maths quiz. We want to see how we can apply indices to our everyday life. That is the interesting thing about mathematics. If you don't see where you're applying the things you are learning, it becomes worrying and troubling as well. So I told you in the first set theory, when you see a word problem, what do? You take your time, you read, and you extract the information. You ask yourself what is a problem and you solve it. So let's see what we have. We are given some experiments looking at concentration of reactants, and it says this decreases exponentially according to a formula. So one, I think green will do enough of the red. So in the first place, an equation was given. I have written it down. Mathematical equations in the problem. 2, where CT and C0 are being defined, I'm extracting my informations. So the first case is to extract your informations. Some terms are being defined, you must know them. C0 is the initial concentration, CT is the concentration after some time. Now to the problem or the question. If the initial concentration is given as that, what is the concentration after 8 minutes? This is a straightforward question. So problem 1, it says it wants to find the concentration after T equal to 8 minutes. And what do? It means you must substitute T equal to 8 into the expression. So I have C0. I don't know, you've been given C0, so it means you must place it here. 1 over 2, 8 over 4 gives me 2. Don't ask me why I got the 8. The 8 is what is given in the problem after 8 minutes. And so please leave your answer in the comment section for me. What's the concentration after 8 minutes? Don't forget, it says it decreases exponentially. This is to tell you that if your answer is greater than, if C8 is greater than your C0, there's a problem. This is how you must think, and not just using a calculator and then just punching and getting a value. You must analyze the problem. It says it's decreasing. It means after some minutes there should be a decay. And so that is what we expect. I expect something less than C0 is 64. My CDH should be less than, I think I wrote greater than here. Okay, so I said if it's greater than, then it is wrong. Yeah. So I expect this to be less than 64. Please give me your answer in the comment section. Okay. Then the second problem, or problem 2, says, how long would it take for the concentration to decrease to 4? It means that now CT is given as 4, but we are looking for the time in minutes. What is T? I go back and I write my given equation. If I want to solve for T, the first thing would be to divide through by the C naught, and that is what I have here. Yes, you got to that. If I want to solve this problem, it will be so cool to find a form in this way, because 1/2 here is the base. It's already in blue, so let me not clean anything. Don't forget 1/2 to the power T on 4 is still an index, the base here, with the exponent or the power as this. And so to be able to apply the indices, I must be able to express this guy in this box here. Let me go back to my green. Where is green? Okay. In a form of 1/2, the same base, to some index. So I can just compare the indexes. So your question is, what is A? You know the value of CT is given. It is something. The value of C naught is given. It was 64. So what is A? CT is given as 4. If I'm able to compare, that means my T is A over 4, and I can find the value of T. So in the comment section, give me the value of A and give me the value of T. If your A is wrong, your T would be wrong. That is it. So we are comparing coefficients or the indexes because we will have the same base. Alright, so in the next section I'll look at the logarithms. Thank you.